Yeah, so today we're going to talk a little bit more about hypothesis testing and specifically about errors that can be made in testing. So there's two types of errors that we can make in hypothesis testing, and those errors are based off of our decision after finding a p-value and comparing it to a significance level. So we're either going to reject the null hypothesis or fail to reject the null hypothesis. And we can't know for sure if that's the right decision, even if our numbers tell us it's the decision we need to make. And so when we make the wrong decision based on our information, we have error. So the first type of error we call a type 1 error, and that's when the null hypothesis is true, but based on our p-value and our significance level, we reject the null hypothesis. So we have a true null hypothesis, but we reject it. And so if we compare this to the criminal justice system, where our null hypothesis would be that the person's innocent. So if that person was actually innocent, but we rejected their innocence and sent them to prison, a type 1 error is sending an innocent person to prison. A type 2 error is when we have a false null hypothesis, but we fail to reject it. So we don't have significant evidence based on our sample and based on our calculations to reject the null hypothesis, even though in reality that null hypothesis is false. So this is somebody who's guilty, but we fail to reject their innocence and we set them free. So a type 1 would be sending an innocent person to prison. We reject a true null hypothesis. A type 2 is when we fail to reject a false null hypothesis, sort of like setting a guilty person free. And so which one of those things is worse kind of depends on the scenario that we are doing our test for. This is just a nice little table you might put in your notes just as a check as you're working through this. If we reject the null hypothesis, but it's actually true, that's our type 1 error. If we reject it and it's actually false, we're okay, we did the right thing. If we fail to reject it and the null hypothesis was true, that's good. If we fail to reject it and the null hypothesis was false, then that's a type 2 error. Now, most of the time, we're not going to know if we made that error. So our significance level that we're using, our alpha, we usually use a 0.05, 5%. That's the probability of committing a type 1 error. So if our p-value is alpha or less, then we would reject the null hypothesis. But if our null hypothesis is actually true, then we would have a probability of 5% if we're using a 0.05 alpha that we'd reject the null hypothesis even though it was true, and that would be a type 1 error. So our alpha is actually related to the probability we make a type 1 error. Similar to that, we have what's called beta, this Greek letter B, and that represents the probability of making a type 2 error. So in a type 2 error, we fail to reject the null hypothesis even though it's false. So getting a value for beta is not something we really can do. What we do know is we can reduce the probability of making a type 2 error by making the alpha level larger. But if we make the alpha larger, the significance level larger, then we increase the chance that we make a type 1 error. A couple other little things about tests. We won't do a ton on these, but we need to know about them. The power of a test is the ability to detect a false null hypothesis. So basically, if we're comparing it to our criminal justice system, our being in court scenario where we are innocent until proven guilty, so our null hypothesis is that we're innocent. The power of our hypothesis test is the ability to detect somebody's guilt. So properly reject somebody's innocent when they're actually guilty. And since beta is the probability of a type 2 error, 1 minus beta gives us the power of the test. Um, remember, type 2 error is failing to reject a false null hypothesis. So the opposite of that would be rejecting a false null hypothesis, which is what we really want to do if possible, and that represents the power of a test. And then the effect size of a test is how far apart is our null hypothesis, so in our case, null hypothesis proportion, the P0, from the true population proportion, which of course we don't really ever know. The further they are away, the bigger the effect. So we'll have some problems where we're going to talk about type 1 and type 2 error in class and what that means sort of practically uh, for a test. Um, make sure if you have any questions about this, you write them down or you ask, and we'll talk about it together.